Hello everyone, welcome back to our channel. Today I'd love to share a light design script we recently developed. It will be a showcase with quick walkthrough of the script. Compared to 3D modeling scripts, time is a new dimension here, which makes both the design and the coordination a little bit more complicated. Of course, there's many different ways to achieve the goal, but we calibrated the script to exactly what we needed. It includes a visual representation, a player system, and a visual design interface. All right, let's dive into it. So first, let me just show you how this works. So it have the set of the group of the lights. So it just have a different layout. This is the design graph of the lights, how the light will behave. All right, so let's play the trigger. You can see, so here is the display. We'll visually see which part of the graph here is playing. And the lights is separated into 4 different groups. And these just 4 different layouts of those groups based on the size of the light cell. They are basically randomly distributed. They are organized into these layers. And what we are actually designing is the graph here. So each color of the curve represents each group of the lights. So you can see we have different options here. Once we put that option, the graph within this red line boundary, it will start play that option. So we can visually see, organize, and manipulate each group's behavior. It becomes much easier to design once everything is visual. So we can just move that curve around and cut and make a copy. Basically, it's just curve, right? You can do whatever you want with a curve, but they are representing lights. And you can also set this timeline to be manually controlled. You can find exactly the moment you want to see on this timeline for this option. And also you can change the color if you want of each group there. So you can change the color here. And this number just tells you how many lights are playing at the moment. For example, here 3 lights are on, and somewhere, yeah, it's only 2 lights on. At the beginning, there are 4 lights on, etc. Help you to understand. Okay, that's what this script can do. Let's dive into the script then. So at first, you can see these are different groups. We organize that in Rhino. So for each layout, like this one, we separate the lights into 4 groups. Here is the black, orange, blue, and green here. So they are based on layer system. You can turn them on and off. Well, we use the layer system so we can borrow these in, just in case in the future, we change our idea or layout. We can just switch the name of the layer and we can reference the new layout into the script. We will generate some surfaces from here and feed this surface into custom preview and assign the color. This is the gradient to that material that will display the color here. But the problem is we do not know the T parameter, which is a domain between 0 and 1. So how can we get these? So my design here is once we get the pin on the timeline, this line will have intersection with all the different graphs. Once we, for example, here we get the 3 intersection here, we can get the z value of these intersections. And we can get a ratio between this z value and the total height of the graph. So here we'll get 3 ratios. And we remap these ratios back into 0 and 1 domain. That should give us like the lights its turn on and off or anywhere in between this gradient. The concept very simple. So how can we achieve that? Here in this cluster, we just have a bounding box. So this cluster is trying to screen out any graph outside of this boundary. Only the graph within will play. Yeah, that's basically the extrusion of the volume of this box, and find points of width on the lines and see if they are within the bounding box or not. And once we get the curves we want to play, we feed that curve into this new cluster. And this is the pen on the timeline. So we will find this is the pen where we fit the line. And here is the curve. We can find the intersection point between the curve and the line. Then we just, here, because when you get the Z here, panel here, we'll have a lot of empty trees, but for future calculation, we want to keep this structure. So I just use a non-item to insert basically zeros into this. So all these three components just place zeros into these empty trees here. Okay. So once we get all the numbers, we sort the number and get the largest one. Use that one to, so this is the height of my graph here. You can see if I measure here, 8 feet. So it equals here. So you can get the ratio of that Z value with this height of the graph, and then remap the number to give us a number between 0 and 1. Okay, so that's basically the core of this script. You just fit that ratio to t, and it will start to show the different gradient of that light. So it mimics the light is turning on and off